Jesus Christ, you people are fucking idiots. Alright, time for another draftphysics.com. Debatephysics.com also, video presentation. So the Iron Gosling has done it again. That is, he's rigged another experiment to fake the results, to force them to come out his way. Alright, so this will be the fourth video, okay, in the anyway, Momentum Rules, KE Fools series of videos where we just follow the saga of a cheater trying to force results. And that's all physics is supposed to be about, is cheat your way to the top, make it look like, it doesn't have to really be like, it can just look like a right result, even though it's, for obvious reasons, flawed and broken and stupid. And of course, nobody will point that out except for me, of course. There's no fair cops involved here except for me. And the comments so far prove that. So not a single comment saying something like, well, where did you test that little thing you made with slides down the frickin' scale? Where did you test that? Oh, that's right, you didn't. Okay. And even, physicist Michael chimes in, this experiment looks pretty good from what I can see. Well, why didn't you ask him to let you see the one that came out perfect for my team? Okay, perfect for my theory. He didn't show that experiment. He just told us that, yeah, I did it all day and it came out with exactly the same weight. So we're supposed to believe he did the experiment where he's just squishing a pile of clay and he got results that are so wrong in that experiment. They were that far off that they were perfect to my theory. And now all of a sudden he's got results that are indicating his theory. That doesn't sound suspicious to you? Well, it should, fuckhead. Anyway, I guess I might read some of this later. We'll see. I mean, it's all junk. Nobody pointed out how the experiment is, again, a piece of shit. It's going to be a piece of shit. It's a gimmick, okay? He broke it again.
Listen very carefully.
Oh, fuck. Time waster.
Kinetic energy is real.
So that's what he has to do. You have to hypnotize people to get them to believe it. It's just for suckers, for believers. It's not science. It's just bullshit. Sell the bullshit.
We don't need to cheat.
Yeah, you do. All right, and you cheat because you can't make any theoretical sense out of what you're arguing. I mean, I've already explained how gravity works. It's a time-dependent force. You can't make 4 units of energy out of 2 units of force. The thing falling 4 times the distance is only going to be in the gravity twice as long. It's just a fact. It can only have twice the energy. It's a fact.
Guys, we'll do some tests.
Tedious, I know. Maybe we'll speed it up till he gets to the experiment.
A ruler suspended in space vertically. This string, the bottom of the loop.
Right, okay, so it's a string, which is an ideal either, right? Strings stretch. Can stretch a lot, actually.
Reaches to the tip of the rope.
It shouldn't be enough, though, to throw this experiment. Like I said, you're looking for twice the difference, so it shouldn't make much difference. And it's the same weight, technically, so they should stretch the same amount. So by my own theory, the stretch of the string shouldn't matter because they're both the same weight.
Ruler. When I attach the weights with the hook to the loop, the one mass will put up to 10 inches and drop it, and then the half mass will put up to 40 inches, measured to the bottom of the loop.
Okay, I don't know if the measurements, let's see, I guess that makes all sense. I mean, the loop is now the point you're measuring from, so it has to fall the 10 inches from loop to loop, so it doesn't matter that the weight's below the measuring point because the weight will land below the measuring point, so no problem there.
And drop that.
So this is the thing. I just saw this in the icon for the video. So I saw this in the icon for the video, and I said, yeah, you can see it yeah, right there. And I'm saying that's what he did. He attached a stupid mechanism to. See, I suggested in the comments they use the Brozosian clay strip idea. A little run of clay down the side here, and let the plunger hit the clay and cut it, and then you'll see how far it goes, because the clay doesn't move. So he already pointed out that when he put a magnet on here, it didn't work because the magnet gains momentum and flies right off. And what's going to keep this from gaining momentum and going too far? So as Newton would say, you know, once a body's in motion, it wants to stay in motion. Once this needle starts moving, it's going to keep moving. There's nothing telling it not to move except for friction. And you really can't create enough friction to stop it immediately, so it's going to keep moving. It's going down, right? So it's going with the gravity. You're giving it velocity, and then you're going to say it's going to stop all on its own. Maybe it's not.
On my scale here, I've made this.
So he moves it really slow. Okay, so yeah, it works when it's really slow, but it's not going to work when you drop the mass from 40 inches.
Little marker thing, which records the greatest displacement.
So again, he's showing it moving really slow. It's going to go really fast. Okay, the half-pound weight is going to travel 40 inches, which is like 80 centimeters, which turns out to be like 5 pounds of weight. So it's gonna land with 5 pounds of force. Well, we'll see how much it is, right? 3 pounds of force.
That's quite useful, isn't it? 1 pound. Half a pound. Now then, reset the scale. Yeah.
Oh, it's time for the experiment. Alright, so let's slow it down again. Okay. So this won't show it, right? Because this is still moving pretty slow. So this won't be the higher velocity test. So it's the higher velocity one. And I'm betting we're not going to see the scale. So we're not going to get a view of the scale moving its little plunger.
Drop.
So we don't even know how accurate this is actually, right? I mean, that looked pretty fast actually. So we don't even know if this is the real weight. I mean, I could calculate the weight, I guess, and say what is the predicted weight of an object. So a 1 pound object dropped 10 inches. So I would argue that 1 centimeter, it's now a 2 pound object. At 4 centimeters, it's a 4 pound object. And then at 16 centimeters, it should be a 8 pounds. Yeah, so no, something's wrong there. Oh yeah, well 10 inches. I got to figure out 10 inches in centimeters. But anyway, so we don't know how exactly. And this is kilograms, so I have to do kilograms in my head. So I have to convert my pounds into kilograms. So yeah, 3 would be 6 pounds. So it's about right. So 3, it should be somewhere under 3 actually, but we'll see. So that's 3.5.
Got to watch out for parallax error.
Who's what? Parallax.
3.5.
Bullshit.
Reset.
$3.5. Got it.
Go.
Sorry, I fell asleep.
$3.5. Just over.
So obviously we don't see the scale move, so we don't get to see if this thing goes further than it's supposed to. So just like the magnet, it gains momentum. As Newton would say, where's your counterforce? Well, the only force you have as a counterforce is friction. So there has to be enough friction to stop it from continuing to move. Question is, do you have enough friction for that? And again, if you create too much friction, then you're going to screw up your results too. Just wasn't the best method.
Reset. Go.
Quick release would also help. I mean, it looked like he moved his hand down in that case, actually, but whatever. Yeah, well, now you got a little bit more.
3.6. Reset.
So I guess he's going to do it 5 times, I guess. So again, we didn't get to see the experiment where it came out perfect for my prediction. So
Go.
we didn't get to see how flawed that experiment was.
$3.6 again.
Well, I don't know. Looked like 3.5 to me, but whatever.
One more, should we do?
No. Let's get on with it. Thank you.
Go.
3.6 that time. Yep.
3.6. Let's try the half mass.
Okay, so just again for the retards.
D.
He's doing this little song and dance, you know. He's just so glib. Anyway, so this will be twice the velocity, but it's half the mass. But it's twice the velocity. That is, the scale will have to measure the weight in twice the speed. So the little plunger is actually going to move twice as fast. It's going to move to the same location, but it's going to move there twice as fast, which means the little thing he put on there is going to now be going twice the speed. And so its momentum is going to have doubled. Its kinetic energy will have quadrupled by their own theory. So by their own theory, they're going to be quadrupling the energy of the little fake reader he built. So the little fake reader is now going to have 4 times the energy it had before by their own theory. All right, and so there's every expectation with 4 times the energy that it's going to be even harder to stop. 4 times the energy. How are you going to stop that little arrow from keeping moving? Oh, that's right. There is no explanation. What magical force is going to come to the rescue and stop it? Oh, that's right. There isn't one.
What should we go? 40, isn't it? Three, 2, 1. Go.
Alright, so let's see what this is. 4. So that's way short of 6. Let's see, it was 3.5. So it should be reading 7. 7.1. And it's 4.8. Okay, let me write that down. So again, you know, the results don't even match their own theory, and yet they publish them as a victory because they don't match my answer. So because they're as far away from my answer as it is from their answer, somehow it's a victory for them. Can you smell that? Can you really smell that, the stink of that? All right, so let's just write these down real quick. And you know, so it's more pathetic than I thought. I thought at least he was going to cheat and get his results to actually come out right. All right, so we got 3.6, not 3.5. All right, 3.6, and what is this? So we got 4.7, maybe 8, but we'll just say 4.7. 4.7. So they obviously needed this to be twice the energy. Okay, it has 4 times the energy, but it's half the mass. I mean, twice the velocity, 4 times the energy, half the mass, so it comes out to 2. So this number should have been 7.2. And instead they got 4.7. Now my prediction would be 3.6. So we know we're 11. Let's see. No, we're 3.6. We're 20 off, right? No, 36. Yeah, no, that's not that complicated, Gary. It's exactly 11 off. So we're 11 from my prediction. And let's see how far we are from 7.2. So 4.7, so that's 3 would get you to 50. And you're 22. So 22 and 3 is 25. So they're 25 away from their theory, okay, and 11 away from mine. And this doesn't have anything to do with the 1.4 thing. I mean, this is, you know, you have to actually measure the weight this time. You can't play your 1.4 game. It's twice the velocity. You're supposed to prove it's 4 times the energy. I mean, if he should do the experiment just with 1 pound weights and just see if he gets the same result, which should be this result, which he didn't get. All right, so again, so it's 11 for mine and 25 away from his. And he's declaring victory. And Physics Michael saying it's a victory, apparently. This is a good experiment. Proves their theory. I don't see how it proves their theory. Do you see how it proves their theory? I can't see how it proves their theory. What it proves is this moron can't do the experiment right. He can't do experiments right. And when he once in a while does, he thinks it's a mistake when he does it right. And then he tries to fix it by breaking it. Which he did. Again. So these numbers, I'm going to bet, okay, just with myself, a little bet with myself, I'm going to bet, okay, that when he does these row of experiments, it won't come out as the same-ish. You know, the other one was 35 or 36. This one's going to be more variance. Because it really is. He is giving the thing momentum, and it probably will go different amounts of distance. But we'll see.
4.6, 7. Reset.
Let's understand, they can't use the 1.4 theory here because they have to actually collect this energy. It's not real energy if it doesn't show up here. You're saying that the kinetic energy is moving the spring, that the spring's compression is proportional to its kinetic energy. So you have to get the kinetic energy to show up here. If it doesn't show up here, it's not real. It has to show up. They have to get 7.2. They have to show it to weigh twice as much. They think it got 4 units of force, okay, and it's half the mass. And the other one got just 1 unit of force, and it's twice the mass. So 2 times 1, and obviously the other case is going to be 1/2 times 4, which is twice as much. I mean, it's going to be 1 times 4. The other one I said was 2. So let's see how far off it is this time.
40. 3, 2, 1, go.
So you can figure it's really a lot of velocity, right? So let's see this number, but it looks like it's not going to be a 4.7. And it's not. So we do have bigger variation. So now we're all the way to 5. Okay, so we're getting more variation because the little plunger is going to slide down that thing different amounts depending on how much friction it incurs. So more friction, then it doesn't quite make it. Less friction, it goes a little further. So now we got a 5.0. Still, that's 22 away from, okay, their prediction. Again, he's declaring victory with an experiment that's not even close to confirming his side. And what's ironic about it is all Brozo making all these complaints about how you're using masses that won't allow it to be. The scale doesn't go to 7.2. He couldn't even use this scale to measure it. So just like Brozo's silly argument about it, oh, they ran out of clay. He doesn't have enough numbers here. There's not enough on the scale to even get twice the energy. There's no 7 on the scale. Hilarious.
There's a 5 that time.
What an idiot. It's really just went 3.5, okay, or 3.6. The difference is it went to 3.6 faster. That is, the little needle moved faster to get to the 3.6. But that's as far as it went. The little plunger didn't go any further than 3.6, and then that thing he made kept going. What a stupid idiot.
Wish I could do it a bit quicker.
Well, you're going to have to do it again. Guess what? Because you've made this another fake video. You can let this fake video stand if you want, but I'll just keep pointing out how, gee, what a stinking liar. Obvious flaw. We don't get to see the scale actually measuring these weights. I mean, you're just telling us that it actually pushed it the right distance. We don't get to see it pushing the right distance.
You have to be patient. 40.
Alright, let's see what the number
3,
will be
2,
this
1,
time.
go.
So the fact that he's not getting the same readings are also, it's a point to make, is that, well, why not? It's probably because you don't have a quick release, because you haven't taken enough care to do the experiment correctly. Mm, 5-0 again.
5 again. The mathematicians can work out.
Oh, so he's not going to bother doing 2 more. So he does 5 of one and only 2 of the other. And again, what he could do is just have the same weight. So to take the half mass weight and do the same experiment with the half mass. I mean the 1 mass. Well, it's a half pound. Use the half pound weight and drop it from 4 times higher and see if it's 4 times the energy.
The relevancy of the numbers.
So this is how much he gives a shit. He doesn't even care to figure out that it's way short of proving kinetic energy, and it's a lot closer to my prediction than it is his prediction. And that doesn't matter to him. Okay, that doesn't matter at all. All he's done is proven it's not my number. It's not, it's not my number. It's like 20% off. The fact that it's 40% or 50% off his number, who cares? Oh, here we go again. Good. He's going to finish
3,
the 2.
2, 1, go.
Thank you.
Five again.
Yeah, well, he's gotten consistent except for that one other one. See, just weird, huh? 3 5s and 1 4.7. What is accounting for that?
I think that'll do to give us an idea.
Okay, so now he's going to cheat. We could have the 1 more, please. Yeah.
I think we don't need to worry too much about kinetic energy.
Okay, so even though it's further off their prediction than my prediction, it's further away from their prediction than my, twice as far actually. It's twice as far away. Even if we use 22, then it's exactly twice as far away from their prediction than it is my prediction. And yet, they are declaring victory. I mean, what other word for this is there except for scum and louse and liar and cheater? Jeez.
All the living fools. But thanks for watching, guys. I know it was a bit dull and boring, but it's taken quite a bit of effort to get that.
Yeah, well, I'm sorry it was taking so much. I don't see it, frankly. I personally can't see that it's all that tedious. You have the scale. All you have to do is rub a little clay on it so the needle tears the clay a little bit, and you'll find out what the weight is. And instead you use some stupid thing that's going to fly off. You know, you kept it from flying off, but you didn't keep it from, you know, measuring the right distance. So I'll just say it one more time. I mean, any idiot should be able to understand. I'm pushing something down. I'm going down with gravity. And as Newton would say, you know, when something's moving, it wants to keep moving, so to speak. And something has to stop it from moving. That is, you have to apply friction. So how do we know there's enough friction to stop the little needle from moving? It doesn't look like there's any, you know. He's obviously made it so it slides easy. And so if it slides easy, then what friction's going to stop it? So it is moving twice as fast, has twice as much momentum. Why wouldn't you think it might go a little bit further than it's supposed to? Well, that's right, you would think it would go a little further than it's supposed to.
You get that sort of working to some degree. Speak to you later. Cheers.
So he calls it working to some degree merely because he broke it from being my answer. So, and that's it. I mean, there's no way around this. I'm just saying I have confidence because I know what gravity is, okay? And I know you're only going to fall 4 times the distance in twice the amount of time. You're only going to be aided by gravity for 2 units of time. And the units of time are the force. You only get 2 units of force. You can only have 2 units of force. You can't have 4 units of energy. All right. I think I reiterated that enough times. All right, so now let's get to some of these moronic. So I went over the comments. There's nothing here pointing out the flaw in this experiment. And there's certainly nothing pointing out how, Jesus Christ, you're way the fuck off. All right, so let's see. Physics Michael. I guess I'm just going to have to keep tearing at this guy because, you know, he's engaged himself in this conversation, and now he's obligated, frankly. I mean, he's made a lot of accusations that aren't true about me straw-manning something, doing this, doing all this stuff that's wrong. And right in front of his face, people are making these obvious mistakes in defense of his physics, and he doesn't even have the integrity to clean that up. And instead is encouraging it, is being supportive of the effort. And the effort is really just to cover up the truth. The effort is don't pay any attention when we get results that confirm some other theory. Only try to deliberately force the experiment to match your prediction. And force it. Do whatever you can to force it to match. All right, this experiment looks pretty good from what I can see. Well, we can all see, none of us could see the scale. So that's sort of important that we don't get to see the scale. Quick question, could you provide the measurement for the distance from the 0 to 5K mark on your scale? Well, why would you need any of this? The scale's already marked. We're already getting increments. You can call those joules, you can call them foot-pounds, you can call them anything you want, but it's already marked in units. So why the hell would you need to know any of this? That way we can identify the spring constant used in your scale and check the specific numbers that you got instead of just the ratio of the results. It's not a ratio of results. You got actual pound weights. Okay, and pounds do convert right into, you know, frankly, joules eventually. You can't make any different distinction, okay? I mean, a Newton is a joule, 10 newtons is a joule. I mean, these are facts. Including the minor correction for a slightly greater fall for the 0.5 pound mass. What? Including the minor corrections for the slightly greater fall. Now, why was it a greater fall? 10 inches, 40 inches. That sounds right. I wonder what he means by the greater fall. Oh, here we go. Since it stretched the scale more. He's really dumb. Since it stretched the scale more. It's comparing dropping from one distance versus dropping from 4 distances. You're not following along at all here? No, I'm sorry, man. This guy is... I don't know what the hell that could mean. Great seeing the evolution of this experiment. So it's great to have experiments covered up. So he gets a result that perfectly matches my theory, and we don't get to see the experiment. We don't get to see what's wrong with it, why it was a no good experiment. Do you think that's great evolution? That's good science. Cover it up. And then fake it. Oh, great. I mean, they're really, these people have no character. Thank you. That's appreciated from a professional like yourself. 0 to 5 measures exactly 38 millimeters. So, that's not the number that's going to help you any. You need to know the 3.8. I'm at 3.6, sorry. I mean, just amazing. So this Michael Falwell, energy in equals energy out. Well, where did you see that? Ke is not free energy formula as some straw man to be. So there's no straw man here. Obviously the results didn't come out anywhere close to kinetic energy being confirmed. So he says here, you can hear that the half mass is simply more forceful. It's supposed to be exactly twice as forceful. It's dropped 4 units of distance. It's supposed to be twice as powerful. Okay, as for it takes more force getting going, 2x the speed. So again, it can't take more force because it's only in the gravity twice as long. So again, they just keep ignoring the facts, just keep spouting the religion. Now let's see, thanks Mike, poorly filmed, who cares? Let's see, performing test is one thing, camera, just all this whining about it. Don't do experiments if you're going to whine about it. I'm not doing them because, yeah, there's no point in me rigging some piece of shit together. This is all stuff science should have done. They've had billions of dollars, hundreds of years. Why haven't they done any of these simple experiments? All right, so Stephen Bro, this is another one of your classic experiments. So that's an amazing statement just because it is classic. All of his experiments are flawed. He didn't measure right in the first experiment. You know, I mean, an obvious mistake. Obvious. Excellent. The needle recorder especially. So this is Brozo. So Brozo was smart enough, or at least he made a recorder, right? He used a little piece of clay, and so the thing comes in, it had a little stick on it to hit the clay, and it pushed the clay. So you could tell how far it went because the clay didn't fly anywhere. The clay didn't have any momentum. It just pushed it out of the way. That's what he should have done here. I posted a comment yesterday, the day before yesterday, on the video, and I left it there for 12 hours. I only, I removed it because Brozo responded to it. And I said, well, fuck that. I'm not interacting with this fucking idiot. That's not happening. With some stupid comment, he said I sounded like somebody, So this is a guy who sounds like, Weezer Templeton, in his famous episode when he met the talking monkey and, they had that whole thing where they did that whole thing. Yeah, that's who he sounds like. It's just, what the fuck? I mean, they can't ever get beyond the subject, can they? Anyway. I mean, just to say it's an excellent recorder when, of course, it's just like his stupid magnet. He's just giving something momentum and then it can skate as far... How can he stop it from keeping going? There's nothing to stop it. The needle recorder especially. So just amazing. It isn't a recorder. Okay, reminds me of John Walker's suggestion to use a skewer being pushed through a hole to record distance moved on an air track. So I don't even understand how that even makes any sense. I'm tempted to say the best experiment ever. So amazing. The results absolutely suck. in that they in the sense that they're between the two theories, and they're closer to my theory by a half. You know, my theory's twice as close. And he's saying the best experiment ever. If not, it's certainly close. I can guess what the plebs will say, whatever that is. They might say something like, "Holy fuck, why are you saying you got results that confirmed your theory when you're 25, 2.5 pounds away?" All right. Thank you, Steve, for those kind words. Just amazing. And he says, sorry, it was so amateurish looking. I mean, bros, those experiments are fucking, besides being, like, filthy. Yeah, anyway, there's just no point. No to apologize for, Ian. It was everything it needed to be as far as I'm concerned. Fake and phony, and you completely didn't get any confirmation of either theory. So you confirmed neither theory. And that's a really great experiment. Very clear result. I mean, can you... I just... Sorry, I don't understand. How is it a clear result? It doesn't match either theory. Without any fancy smancy stuff. Like being somewhere closer to... Well, it's closer to my theory again. Twice as close to my theory. Okay. If I'd come up with the arrangement 2.5 years ago, instead of rolling one masses and two masses into springs, I would have saved myself a lot of bother, blah, 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 blah. Right? The silly rolling coins into things. You know, the whole rolling problem again. All right, so let's see what this lie is here. This has got some math in it. 3.6% short of 2x. So I don't know how he comes up with that. Let's see this. This is very accurate. If E equals 1/2, assuming K equals 1, so he's doing the K thing. For a 1 mass, so 1/2 times 1 times 3.6 equals 6.48 joules. 3.6 squared, and he got 6.48? I don't think so. But anyway, so that's 12. 3.6 squared is 12. So, I mean, this math isn't even right. 3.6 squared has to be something like 10. Right? So you got 10 times 1 times a half is 5. Well, anyway, it doesn't matter. For the half mass, blah, 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 12.5 joules. So what does this have to do? Where have you shown the real pounds here, you idiot? You don't have real numbers here anywhere. This doesn't make any sense. So 5 squared. So how did he come up with this one? 5 squared is 25. Half of that is 12. So how are these numbers? So he's saying... Let me just think about that. I mean, there's got to be a flaw in here somewhere. I mean, it's a weight. Okay, all right, I'll pause and see if I can figure out what he's saying. I mean, obviously it didn't go twice as far. It didn't weigh twice as much. It has to weigh twice as much. Oh, okay. I found the mistake. He has 1 here and 1 here. So he forgot that one of the masses is a half mass. So obviously it's times 0.5 here, or you use 2, but you can't do this. So he's got the mass numbers wrong. It wasn't the same mass dropped, moron. It was half the mass. So let's see what these replies are. I mean, it's just kind of funny, right? I mean, they're going to reply to wrong numbers. And will they point out that they're the wrong numbers? All right, thank you for that. This is the square root of 2 thing. 1.4 again, question mark. No, you're not allowed to use the 1.4 escape here. You have to actually show that it has twice the energy. You can't show that it has 1.4 the energy because that wouldn't confirm your theory. You have to show that it actually had twice the energy. And obviously the moron did the math wrong because the masses aren't correct. So he's using the kx thing. So I don't know It's really hard to figure out what, he's saying the spring constant is 1. He has no reason to say that. I guess that would be part of the reason why it's fucked up. But if you're going to do the kinetic energy formula, we're looking for a result where you're saying it's twice the energy. If the spring stores kinetic energy, you can't play this game, of changing that. All right, but anyway, he's got the K is the spring constant, and so he took mass out of the equation. So I don't even understand how that makes any sense to anybody. So obviously this equation is just as broken as this 1/2 kx squared is just another pile of crap. It's just a way of converting momentum numbers into fake kinetic energy numbers. These aren't real numbers. These aren't real joules. You could sort of understand that something has to weigh twice as much to have twice the joules. It would be ridiculous to say that isn't true. All right, thank you for that. It is the square root of 1.4 thing now. Yes, also the joule is probably 10 to the third smaller than what I have. I don't know what that even means. All right, here are the numbers for the mathematicians. Mass, 1 pound. Yes, that's important. The masses are important. It's a gravity experiment. I mean, not to have the masses in there would be rather ridiculous. Okay, drop height changes. Hook in line with tape measure reading. 10 to 40 inch change in height hookup. Yes, we already did this. Altitudes are 1040. Lower end tape measure. What is all this stuff? Okay, so this is all just a waste of time. There's nothing here. Marker displacement. So what did you prove here? There's nothing here. Okay. All right. Thanks for that, GP. Appreciate the interest. What is there? 6% error maximum KE ratios. So obviously it's a much bigger error than that. It's supposed to be twice the weight. There's no other way of getting around it. They were supposed to come up with twice the weight. Anyway, it's just amazing. Of course, Gary will say it's a failure for both theories because as KE predicts twice the energy, the gauge should deflect twice the distance. Yeah, I don't understand. So I explicitly state that, yes, it's going to be the same reading on the scale. I don't have some catch to use. I don't have some escape where I can say, no, there's a reason why it's not going to be the same. I mean, you can't say it has 4 times the force has affected it, all right, and that it's half the mass, and then tell me it doesn't weigh twice as much. If it has twice the energy, or twice the force it collected 4 units of force, therefore it has twice the energy because it's half the mass. If you're going to say it, then it has to show it on the scale. If the 3.6 number is right, the 7.2 number has to show up. You can't pretend. You can't say the spring stores kinetic energy and then say, no, it doesn't. The hypocrisy here, just amazing. I'm sure if the spring compressed to 7.2, even though there's no 7 on his scale, he would have been really glad and happy with those results, because that would have confirmed twice the energy. So this is all just such a pile of crap, this rewriting the history. I mean, it's clearly closer, 11 from my theory, 25 from their theory. Fuck. All right, there's no, you just can't, these people are so dishonest. All right, so the obvious shot is we didn't get to see that little plungery thing worked. So he didn't show us, so he just should put the camera on it, drop the weight, and let us just see the scale and see if that little plungery thing keeps moving. If it keeps moving, which you would expect it would, because it's going twice as fast, then, oh, sorry, you're going to have to do your experiment over again. Your fake experiment. Okay. So anyway, 8 thumbs up with 45 views for a video that confirmed neither theory, and we don't get to see the scale actually reading the results. Oh, I mean, this is so disgusting. So anyway, it's just going to make this story more interesting for somebody to read in the future. Just how amazingly crazy it was that this is what people resorted to. Instead of just doing these honest, simple experiments and conceding that, yeah, momentum works, they did all of this to rescue a theory that has no credibility. It has no evidence supporting it. All it is a mistake. It's a 200-year-old mistake, and they just can't let it go. A 300-year-old mistake. And they just can't let it go. They can't admit they made a mistake 300 years ago. They bought a mule, and it's not going to win the Kentucky Derby. Anyway, so whatever. I'm just... I mean, yeah, that's all you can do. Is just face palm the world and say, fuck. You're all way too stupid. Just way too stupid, way too dishonest. But we'll see. I'm just saying that we'll see if somebody shows up with a little bit of integrity and admits this isn't what science should look like. Alright, anyway, till the next time, and such and so forth and whatnot. Shit.